Moment works in 3D the same as 2D, but due to the complexities of visualizing things, we usually go to a Cartesian vector formulation. You can use scalar to do the X, Y, and Z 3D as well. Don't get me wrong, but it gets hard to see very quickly. Before we get into the nuts and bolts of that, we need to recall some of the mathematics of your past, like the vector cross product. So vector C here is going to be the cross product of A cross B, and you say it like that, A cross B. So C is equal to A cross B, and the answer, vector C here, is that. It's a vector. It's not a scalar. It's got I, J, and K potentially, right? In this case, it would only have J as it's drawn. But that's just this example. You can have vectors acting in all different directions. And it's got to be, A cross B is not the same as B cross A. As a matter of fact, it's the negative of it. So we're going to have to put up everything in the right order when we do our vector math. And note that C is always perpendicular to vectors A and B. So if you're crossing A and B, so you're doing A cross B, then you know that their cross product is actually going to be perpendicular to the plane caused by those two vectors. In this case, the XZ plane is where those two vectors lie. That's why C is pointing in the Y. Okay, more about the vector cross product. The way we're going to do it is we're going to use a determinant. And this is how it's going to look. We're going to put this is going to be our answer over here. It's going to be our moment when we do it eventually, but we're just looking at C is equal to A cross B. C would equal the determinant of, and in your top row, you just go I, J, K. Just I, J, and K. Those are the direction vectors for X, Y, and Z. So those aren't going to be numbers in this particular math. This is going to be the letters I, J, K across the top. When we get to moment about a line or axis, then there will be numbers up there, but we'll get to that later in this lecture. The second line is going to be the first vector. If you're doing A cross B, you got A there, and then B is going to be your last line. So what those are your components in the X, the Y, and the Z for each one of these vectors. So whatever your I term is for A, whatever your J term is for A, and K term, yada, yada, yada. So then when you do that, you've probably learned in the past, you can draw a vertical. If you're doing the I term, you draw a vertical line through the I and a horizontal line through the I. And so you're going to multiply I against this little subdeterminant over here, which is AY times BZ minus AZ times BY. That's what you see here. You do the same thing with J. So now you draw a vertical line through J and a horizontal line through J. And so then J is going to be AX times BZ minus AZ times BX. Okay, so it's all acting exactly the same. The only big thing here is that the second term, the J term in your moment or cross product calculations, the J term in your cross product calculations is always going to have a negative sign out in front. It doesn't always mean that the answer is going to be negative for that value. That term's not always going to be negative. It just means there's a negative sign out front. So if this is negative and these values are negative, it'll end up being overall positive, but you get the drill. Then a plus sign, and then vertical line through K, horizontal line through K. So then K is going to be multiplied times AX times BY minus AY times BX. So note all of these minus signs that show up in this work. And realize that the cross product follows the right-hand rule. So if you're crossing A and A cross B, you're going to get the vector pointing up in the direction of your thumb. Moment calculations using the cross product. So we just learned about how to do the cross product. Now let's figure out how to use it in the sense of moment. So if we want to calculate the moment about point A right here, due to the force acting up here at this point B, I need to determine this position vector right here. And this position vector, RAB, is going to start at the point I'm summing moments about. So it says moment about A. So the first letter in your position vector is going to be A. And then the last letter is going to be a point that is on the line of action of the force. And if you look at how this force is drawn here, the only place we know that it's acting is at B. It really is acting through infinitely many points up and down. Well, we don't know where those are. We can't define them, so of course we're going to go to B. If we knew a different point that F was acting through as well, we could do A, whatever that one is. RA, C or D or F or whatever it is. But all we know is B. So we can say the moment M sub A is equal to RAB cross F. So RAB needs to be a vector in IJK, and F needs to be a vector in IJK. And then we do our determinant like this. Again, we write IJK across the top, and then we take our position vectors X, Y, and Z terms, the coefficients, and then the X, Y, and Z coefficients of our force. And doing the same deal that I walked you through on the last slide, this is how the math works out.